Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. The topic is force on current carrying conductor when placed in magnetic field. Students, we know that when current flows through a conductor or a wire, it becomes magnet. There produces magnetic field around it. And when a current carrying magnet is placed in the magnetic field of another magnet, both the fields interact with each other, resulting a force that acts on the current carrying conductor. It is our today's topic. Let us consider this diagram in which a current carrying conductor AB is placed between the two poles of a horseshoe magnet. There are two magnetic fields. One is the field of this magnet that is acting downward in this diagram, and other is the magnetic field produced due to flow of current in this conductor. The arrangement is such that this conductor can swing between the poles of this magnet. When these two magnetic fields interact with each other, there develops a force on the conductor. Now, the magnitude of this force exerted by the magnetic field of magnet on this conductor depends on different things. Let us discuss them one by one. The factors on which the force depends. Number one is the current in the conductor. More the current flowing in the conductor, more will be the magnetic force. Fm means magnetic force acting on current carrying conductor placed in the magnetic field, and number one, it depends upon the amount of current that is flowing in the conductor. Number two, it depends upon our strength of the magnetic field. The force depends upon the strength of the magnetic field. Stronger the magnetic field, more the force it will exert on current carrying conductor. Number three, length of conductor. Longer the conductor passing through the magnetic field, more will be the force exerted on it by the magnetic field. And number four is the angle between magnetic field and current carrying conductor. So magnetic force is proportional to sine of the angle that the current carrying conductor makes with the magnetic field. Now students, we combine all these four facts in a single equation. So we get Fm means magnetic force is proportional to ILB sine theta. I is the current, L is the length of conductor, B is the strength of magnetic field, and theta is the angle that the current carrying conductor makes with the magnetic field. Now removing sign of proportionality, in this case the constant is 1, so it is the mathematical expression for magnetic force exerted by magnetic field on a current carrying conductor placed in it making certain angle theta with the magnetic field. Now students, when the force will be maximum, from this equation the important thing is the orientation of the conductor in the magnetic field, the angle at which the conductor is placed. If this angle is 90 degree, what do you mean? It means when conductor is placed perpendicular to the magnetic field. Look at this diagram. Here a current carrying conductor is placed perpendicular to the magnetic field. If these are the poles of a magnet and there is a magnetic field, so look at this angle, the conductor is making an angle of 90 degree. If angle between conductor and magnetic field is 90 degree, you know sine of 90 equals to 1. Putting this value of sine of 90 here, we get force maximum equals to ILB. So the magnetic field exerts maximum force on a conductor if it is placed perpendicular to the field. And the other situation, that can be minimum force. When the force acting on the current carrying conductor will be minimum if theta equals to 90 degree. It means that the conductor is placed, current carrying conductor is placed parallel to the field in the direction of field. So you know sine of 0 equals to 0. Angle made between the current carrying conductor and magnetic field is 0. So sine of 0 equals to 0. Putting this value here, we get minimum force, and that is 0. It means magnetic field exerts no force on a conductor that is placed parallel to the magnetic field. This is all about the magnitude of the magnetic field. Now students, what will be the direction of this force, the direction of magnetic force? To find the direction of magnetic force, there are different methods, and one is called palm rule and other is called Fleming's left hand rule. Let us discuss them one by one. Consider again a magnetic field due to poles of a magnet. If the field is directed from left to right, here is the direction of field, and here is a conductor placed, that is current carrying wire is placed, flowing current in this direction, in which current is flowing in this direction. The fields, these two magnetic fields will interact and there generates a force. What will be the direction of this force? Here in this diagram, the direction of magnetic field is from left to right. Direction of current is coming out of the page, out of the board, out of the screen. Force will be directed perpendicular to both in upward direction. How we determine this direction of field? Let us first discuss the palm rule. Consider the palm of your right hand with straight thumb, such that fingers are indicating the direction of magnetic field, thumb points in the direction of current, then the palm of right hand is in the direction of magnetic force. So here look at this situation. If current is flowing out of the paper and thumb will be pointing outward, fingers will be pointing from left to right, then the direction of palm will be upward. So it is one rule that we use for finding the direction of magnetic force that magnetic field exerts on a current carrying wire. Another rule that we use is known as Fleming's left hand rule. According to this rule, the thumb, first finger and middle finger of left hands are considered in stretched position perpendicular to each other. First finger points in the direction of magnetic field, middle finger in the direction of current, then thumb of the left hand points in the direction of force. Either you can apply this rule or this rule to find the direction of magnetic force exerted by magnetic field on a current carrying wire. Students, this is all about the force exerted by magnetic field on current carrying conductor placed in it. Students, thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.